Hey, what's up, guys? Chung here again. And so today I want to talk about this LeetCode problem, 128, longest consecutive sequence. This is kind of like one of the oldest problem. So the reason I want to talk about this problem is because during like last week's weekly contest, the one of the problem is really similar. It's almost the same, and not the same, but it's quite similar comparing to this one. So I figured it's good time to revisit this problem, just so that we can try to summarize some patterns out of those two problems. Okay, so you're given like an unsorted array of integers. Find the length of the longest consecutive element sequence. So your algorithm should run in O of n complexity. Okay, I mean, if there's no such constraints, we can simply sort, right? We can simply sort the the array and then we just count, right? We just start from the smallest one and then count it. But since it does not allow us to sort it, otherwise it's going to be a O of n log n time complexity, right? So if you guys still remember how did we solve that last week's weekly contest, basically the other one was there's like a n bits long of the n bits long of the zero here. Okay, and every time you just flip one of them into one. Okay, okay, and in the end, all the zeros will be flipped to one. And the question is asking you to find the latest step that still has the m group of ones. Okay, so in that problem, what we did was basically we're maintaining like two arrays. The first one is the length, the the count, right? The count of uh basically the counts of each position. Okay, and then another one's like a group counts, basically counts the current consecutive length, the basically the counts of the length. Okay, if there's like two groups which has two ones, and then the count of the group of length two will be two. So I think for this problem, we're gonna use the similar like concept here. Basically, we're also gonna have like a length here. Okay, we we're also gonna be using a length of but here we cannot use like we can't use the array here because the number is unbounded. Okay, that's why for this problem, we have to use, instead of array here, we need to use a hash table here. Basically the key will be the number. Okay, the key will be number and the value will be the length for that number. So basically what this means, it means that, let's say we have like two, three, and sorry, two, three, and four. Okay, here we have five. Sorry, here we have 6, 7, 8, 9, and 10. Okay, so the left side, right? The left side, the length is 3, and the right side has a length 5. So now, if we see if the next number is 5, okay, if we have a 5 here, basically we check if the left side and the left side is 3 and the right side is 5, then basically the new length, right? The new length of this whole array will be 9. Okay, but since we only need to update the start and end point, okay, so in this case we only need to update the length of 2 and the length of 10 here. Okay, but one more thing is that, for this problem, since there could be like duplicated numbers, right? And we don't want to I mean recalculate in 2 and 5 more 2 and 5, right? 2 and 10 like multiple times. Why is that? Because let's say we have 5, okay? So for 5, now the length of 2 becomes 9, right? and the length of 10 is also 9. Now let's say later on there's another 5. Okay, if there's another 5 there, so what's gonna happen, right? We're gonna uh, try to calculate the 5 one more time, right? So basically it's gonna be 6 and 4. I mean, so basically we don't want to recalculate double counting this 5. So that's why besides the 2 and the 10 here, besides start and end, we also want to mark, basically add the current number into this our hash table. So every time when we have a number, we the first thing we do is we check if that number has already been seen before. Okay, so let me try to code these things here. So length, like I said, we're gonna have like a hash table, and now for number, right? For number in numbers, okay. Basically, if number not in length, okay, then we do the following. So first we left equals to right equals to 0. We initialize the left and the right length to 0, and basically if the number minus 1, okay, if the number minus 1 in length, okay, then we know the left will be equals to the length of number minus 1. Okay, same thing for the right, for the if number plus 1 in length, okay, then the right will be the length plus number plus 1. Okay, so that's how we calculate that, right? I mean, since we initialize the value of for left and both left and right to 0. I mean, basically if we're at 2 here, the left there's nothing on the left side, okay, then we simply like we just don't do this, and the left will be 0. Now, so now all we need to do is we just need to update the new beginning and end, okay. um, mm, plus right, okay, equals left plus right plus 1. Cool. And yeah, I think here we can have like an answer here. System max size. Okay. Okay, so and every time when we have a new length here, right, we simply do an answer uh goes to the answer. Sorry. So this one, since we're getting the longest, so the starting point will be 0. So max dot left plus right plus 1. Okay. And in the end, we simply return the answer here. So let's try to run the code here. TH. Okay. Cool. So the test case passed. Let's try to submit. See, so this one it failed, because so why is that? Because we didn't add the current number into our hash table here, so that when we have like a 5 here, uh, So the issue is this. I mean, let's say we have like we have a 3, 4, 5, and then we have a 7, right? So basically on the left side, the length is like is 3, right? On the right side, it's 1. So at the first time when we have like 6, okay, we add a 6 here, and then we're gonna update uh 3 and 7, both 3 and 7 to be 5, right? So now the length of this one is going to be 5 and a 5, okay? But if we don't store the value for the 6 here, so what's going to happen? Let's say there's like another 6 coming in here. So it says, okay, so the 6 is not in the length here. So I'm going to try to do this length calculation one more time, right? Basically, what's going to happen, right? So uh, basically now the left side, okay, so the left side, as you guys can see, it's still 3 here because the 5, right? The length of 5 is still 3 here. That's why the left side is 3, but the right side, what's the length of the right side? The right side is 5 now, okay? Because we have already updated the 7 to 5. So now the new length will be what? 3 plus 5 plus 1, it's going to be 9. So we're going to update 3 to 9 and 7 to 9, which is wrong, okay? Right. So that's why, I mean, not only we need to update the starting point and the ending point, we also need to update the number itself. Okay, basically the length of the number. Okay, so that, I mean, this if check really works as expected. Submit. Cool. So see, this one works. Basically pass. Basically, I mean, this one's using the same concept. We're maintaining like a length for each number. And every time when we have a new numbers, since this problem is asking us to find the longest the consecutive element sequence. So basically, if the current number is 5, and we're looking for 4, 4, and 6, and we'll check what's the length of the current 4 and what's the length of current 6. Okay, because with the length here, then we know. Let's say if the length of 4 is 2, let's say 3, it means that, okay, so there will be a 2, 3, 4 on the left side. So if the length of 6 is 2, then we know on the right side we have a 6 and 7, right? That's the two parts here. And with the length here, now we have the new length, right? We can just simply update the new starting point, which is 2, and the new ending point, which is 7, to the new length. We also update the current 5 to make sure we're not processing the same numbers more than one time. Okay, and in the end, we simply like update. We keep track of the maximum numbers. Okay. Uh, cool. I mean, so if the left side or right side doesn't exist, that doesn't really matter. That because we initialize at 0, right? So if it doesn't exist, the 0 will not affect our result. Cool. So that's how it works for this one. And the time complexity, of course, is O of n, right? Because we're only doing constant time of operation for each of the number here. Okay. And the space complexity is also O of n. Cool. Actually, there's another way of solving this problem. Actually, let me try to. I think it's more intuitive when more brute force. Basically, another way of doing this problem is basically we just do hmm, we simply check. I mean, we convert all the numbers into a number set. Okay, I'm gonna simply briefly write about that solution here. Basically, we're gonna convert that numbers into a set. Okay, and every time, and we loop through the numbers here. And So and every time when we have a numbers, right? We check. Uh, we first check if there's a number on its left. If there is, we simply skip that. Why is that? Because not, I think the idea for this for the second solution is for every numbers. Let's say if we have a, for example, this one here. We have four here, right? We check if three is in the list. If there is, we just skip that. I think the purpose of this for loop is we try to find the smallest number, okay? And then from the smallest number, we try to uh, increase the number one by one until the new number is not in the list. And then we know, okay, we find a length, right? A length of consecutive numbers, and then we just update our answer. Okay. Basically, if number minus one is not in num set, okay. Uh, then we do length, right? Length equals to I think we can do it equals to one, right? Basically, while number plus one is in the numbers, okay. We simply do uh, number equals to plus one, and then length plus one, okay. And then we have an answer here, 0. Okay, we simply do this, right? And once the while loop is finished, then we know, okay, we find the longest consecutive for this as this number to be the starting number, right? So here dot length, okay, and then we simply return the answer here. TU RN, okay, okay, submit. Yeah, okay. So this one, I mean, it seems like we have seems like we are doing like a while loop inside of this of a for loop here. Mm, but this solution is also like a O of n. I think there's like a proof. You can prove, right? Uh, each element will only be accessed, only be visited only twi at most twice. So so this solution is also a O of n time complexity. Mm, I mean. Some of you might think, okay, so this is much easier to understand. Okay, I'm gonna try to use this one in the future. But in my opinion, uh, the first one is more important because the idea, right? The or the or the technique of keeping the length out at the starting point and ending point can be applied to other problems. But this one, I mean, maybe it only works for this one specific problem. But this one, as you guys have seen during this week's weekly contest, we can utilize, right? We can utilize this kind of concept or idea, right? That we every time when we try to merge two parts, okay, we update the new the new uh the new array's starting point and ending points with the new length, okay, and with the new length we can do a lot of things. So in this case, it just happened to ask us to return the length. But in the other problem, right, it asks us to find what's the latest step that we still have this one length. Okay, cool. I think that's it. Yeah, for this problem. Yeah, thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.